we're going to take a break from looking at systems of equations to dive into what are called linear inequalities. Now, we haven't talked much about inequalities yet this year, so let's go over some of the basics. There are 4 inequality signs that we're going to talk about in this class. The first inequality sign is less than. Less than is made with your left hand. So if you look at the inequality shape right here, it looks like a little Pac-Man mouth. If you look at your left hand, that is the same shape. So less than is our left hand. The next symbol is called greater than. Greater than is your right hand. So see how this chart, it has greater than and then right hand. So if you look at your right hand, it makes the same Pac-Man shape when you tilt it to the side. The next inequality sign is called less than or equal to. And again, it's your left hand, but it also has an equal, half of an equal sign underneath it. And last but not least, we have greater than or equal to, which is, again, your right hand with a line underneath it for the equal to sign. Now, you can remember your hands, but it might also be helpful for you to remember leg. This little symbol up here is going to show up on your supplemental aid, which is the light blue sheet that we give you in class. And it reminds you what each of the symbols are. If you spell out leg, on one side you have the less than symbol, on the other side you have the greater than symbol. And in between, of course, you have your equal tos. There's the E. So all these things might help us remember what the inequality signs are. But more importantly, today we're going to be writing inequalities and graphing inequalities. So the second row of this column underneath each little piece right here for each symbol is a hint for you to remember what words translate to that symbol or how to graph and shade for it. Less than means that we're looking for words like smaller than. Greater than means that we're looking for words like more than. Less than or equal to means that we're looking for words like no more than, at most, which seems weird because we're doing less than and we're talking about no more than or at most, so these are tricky. Greater than or equal to is no less than or at least. So when you're trying to write an inequality, make sure you refer back to this chart right here. In fact, if you have a highlighter, a pencil, any sort of thing to make this bolder, I would highlight, circle, star, underline this chart. This is going to be very helpful for you today to write and graph your inequalities. Now, I didn't talk about the last little initials in each box, and that's because it has to do with graphing. Now, when we graphed a regular line or a system of lines, we are able to find one solution. It's where the lines crossed, where's the line crossed the x-axis. All of those things are solutions, but inequalities don't have just one solution. They have many solutions. All of their solutions are found in the shaded region or shaded half plane or on the solid line, but not, this is important, not on a dashed line. Okay, so there is going to be a difference in the boundary line that you draw today. If you look back up at the chart, we have all of the last letters up there. If you look at less than, it says BD. That stands for below and dashed. So less than is going to have a dashed boundary line and be shaded below the line. AD stands for above and dashed. So greater than is going to be shaded above but have a dashed line. For less than or equal to, the BS stands for below and solid. So it's going to have a normal solid boundary line but be shaded below. And the AS for greater than or equal to stands for above and solid. So yeah, that's a lot of things we have to remember now that we're graphing inequalities, but you have this chart here to remind you. If you want to draw on the arrows and the dashed and solid lines that I did, that might be helpful for you here on your notes. But an inequality, when we graph it, is going to look something like this. We can look at all of these points and determine if they're in the solution set, if they are a solution. Let's first look at this graph. Some things I want you to notice about this graph is that it has a dashed boundary line, which means that any point on that dashed boundary line, like this one right here, will not be in the solution set. But anything in the shaded region, like these 2 points here, is a solution to the inequality. Obviously, this one's not even in the shade, so it's not a solution. But if you look at the graph with the solid line, again, anything in the shade is a solution, not in the shade, not a solution. But if you notice on the solid line, that point is a solution. So that's different from the dashed line, which is why it's important to remember if you need to have a dashed line or a solid line in your solution set. Basically, the reason that happens is because we're saying for a dashed line that it either needs to be greater than or less than, not equal to. And the line represents the equal to part. So on both of the symbols that say less than or equal to, greater than or equal to, the line becomes solid because we're including that boundary line in my solution set. Great, let's go on the inside. So what our goal today is to be able to write and graph inequalities. So you're gonna have a bunch of situations here that we need to write and graph an inequality. These are all real world things that may happen. Number 1 says Mandy is buying plants and soil for a flower bed for her mom. Bags of soil cost $5 each, and each plant costs $10. She can spend no more than $40. Write and graph an inequality that represents the situation where X is the number of bags. Let's define that variable. And Y represents the number of plants. All right, we need to find some information here. So here's what I know. I know that since we're talking about bags of soil and plants, that bags of soil cost $5 and plants cost $10. And that we need to have no more than, circle, star, highlight, underline, no more than $40. Y'all flip back to the front of your notes. What symbol means no more than? Hopefully you noticed that no more than was the less than or equal to symbol. NMT is underneath less than or equal to. Great, so we can write this equation just like we practiced. We give $5 to every bag of soil and $10 for every plant, and she wants to spend no more than $40. One thing I want you to immediately remember is that with the less than or equal to sign, we're going to be graphing this with a solid line and shading below the graph. But we cannot graph this right away. We need to solve for y. So I'm going to take this x to the other side. It changes signs. This would be 10y less than or equal to negative 5x plus 40. Notice how I didn't change anything about that inequality sign. Don't accidentally change it back to an equal sign. It's still an inequality. We're going to divide by positive 10 on both sides, which means my sign is good to go. And I would have negative 1/2 x plus 4. Great, I know how to graph that. So I'm going to grab my handy dandy y-intercept and plot that point. And then I'm going to go hop down 1 and over 2 so I can graph another point. Grabbing a straight edge, and I'm making a solid line. Remember, for less than or equal to, that's a solid line. But then we also need to shade. We said that this should be shaded below. So we're going to shade in, like coloring in, all of the things below that line. All of the points represented by the shaded region are considered solutions to this system. Now, some things I want us to notice about this answer is that some of them don't make sense. Okay? Here's one that makes sense. This is the coordinate 1, 1, which means Mandy could buy 1 bag of soil and 1 plant. But if I were to plot this point right here, this is the point -2, -2. Does it make any sense for Mandy to buy -2 bags of soil and -2 plants? No, that doesn't make sense. You can't buy negative things. So we would have to remember that after we do this correctly, we have graphed it correctly, that we also have to have reasonable answers. So this would not be a reasonable answer, but this one would. Cool. Let's look at the next one and see if we can write and graph that inequality and situation. Jennifer is planning for her art project. So she has a max budget of $10 for supplies and needs paints and popsicle sticks. Hobby Lobby is selling bottles of paint for $2 and boxes of popsicle sticks for $3. Write and graph an inequality that represents the situation where X is bottles of paint and Y represents boxes of popsicle sticks. All right, that's what our variables are going to be. Let's look for our information. She says that she has a max budget of $10. So that can go no more than $10 because that's her maximum. Hobby Lobby is selling bottles of paint for $2 and popsicle sticks for $3. All right, that's all the information I need to write this. So let me give $2 for every bottle of paint, and $3 for every popsicle stick. And I know that has something to do with 10. Now that is her max budget. Can she go over $10? Can she buy under $10? Can she buy things that are exactly $10? Yeah, that helps me realize that the bigger number has to be 10, but it can also equal 10. Max budget means no more than, or at most, which translates to our less than or equal to sign. Great, we need to graph this. We can't graph it in standard form, so we're going to go ahead and solve for y. We're going to take that 2x to the other side. It becomes negative. This is 3y less than or equal to negative 2x plus 10. Divide by 3, divide by 3, divide by 3. That was a positive number, so my inequality sign stays the same. And then I have negative 2/3 x plus 10/3. You're probably like, Miss Quigley, you gave us the ugliest y-intercept to graph. You're right. This is approximately 3.3, so we're just going to estimate this today. Okay? So here we go. I'm going to plot a coordinate point at 3.3-ish, which is just a little bit above 3. And I'm going to hop down 2 and over 3. There's a good estimation of what this will look like. Now, we need to decide if this is going to be solid or dashed, above or below. With the inequality sign less than or equal to, do I shade above or below with a dashed or solid line? Very good. This is going to be below and solid. So I'm going to go ahead and draw a solid line between these two coordinate points. And I'm going to shade in below that line. Just so happens that we used the same inequality sign here. Just happened to be that that's what Mandy had. She had a max budget. Now let's talk about some reasonable answers here. Anything in the shaded region is reasonable. So here's the coordinate point 1, 2. Can Mandy buy 1 bottle of paint and 2 popsicle sticks? Yeah, she would be within her shaded region, which means she would have enough money for that. Can she buy 4 popsicle sticks and 4 paint bottles and 4 popsicle sticks? No, she doesn't have enough money for that. That's out of the shaded region. Can she buy 3 popsicle sticks and 3 paint bottles and -2 popsicle sticks? Technically, that's in the shaded region, but it doesn't make sense in real life because you can't buy negative things. So again, remember, after we do this, when we're using real world things, we have to make sure that our answers, our solutions, make sense in real life. I'm going to let y'all try number 3. So I want you to go ahead and read through number 3, see if you can just write the inequality. Don't try to graph it yet, just write the inequality. So here's what I got so far. If we let X be the first job hours and Y be the second job hours, like it says to, it says that her combined work hours, which is why I've used this plus sign to combine the hours from both jobs, should be no more than 48 hours. Okay, no more than on my chart translates to less than or equal to, because she can work less than 48 hours. She can work exactly 48 hours, but she can't work more than 48 hours. Great. Okay, I'm going to let you guys try to solve this for Y as well. Solve it for Y and make sure that you can solve an inequality for Y. Don't graph it yet, just solve for Y. Hopefully you noticed that this was a very easy one to solve for Y. Y had a coefficient of +1, so after just moving the X to the other side, I have it solved for Y. This means I have a y-intercept of 48 and a slope of -1. Okay? Did I plot the y-intercept correctly? No, I didn't. I put that on the x-axis. That's not right. We'll go ahead and put this on the y-intercept and graph. Now my slope is down 1 over 1, but my scale actually goes by 6s. So when I hop down 1, I'm actually hopping down 6. When I hop over 1 box, I'm still hopping over 6, so that's fine. 1 over 1 is the same as 6 over 6. Now, do I need to graph this above or below with a solid or dashed line? Yes, less than or equal to is again below and solid. So I'm going to take my straight edge and I'm going to make a nice solid line between these 2 points across the whole graph. And then I'm going to shade below. So the shaded region here represents every combination of hours between her 2 jobs that she could work and still work no more than 48 hours. Which means that she could work 18 hours at the first job and 12 hours at the second job and be good to go. She could work 12 hours at the second job and 36 hours, at the first job and 36 hours at the second job and still be within the region. All of these are possible combinations for how much time she can spend at both jobs. Cool. This last one's really cool. It says, Caleb and Preston are ordering cookies for their mom. They can choose any combinations of chocolate chip and sugar cookies for her and want to make sure they spend at least $40 on their mother. They're good kids. Chocolate chip cookies cost $3 each and sugar cookies cost $2. Write and graph an inequality that represents a situation where X is chocolate chip cookies and Y is sugar cookies. Okay, so here's what we know so far. We know that the letters X for chocolate chip cookies and Y is going to be sugar cookies. We also know when we read through this thing that they want to spend at least $40 on their mother. Okay, we also know that chocolate chip cookies are $3 and sugar cookies are $2. Okay, so if I make sure I line up the $3 for the chocolate chip cookies and the $2 for the sugar cookies, it's going to need to be at least $40. Look back at your chart. What symbol is at least? Yeah, hopefully you notice that at least means that they want to spend more or equal to $40. They're trying to spend get a nice little gift for their mom. Okay, if we need to graph this though, we need to solve it for y. We're going to take the x to the other side. We'll have 2y greater than or equal to negative 3x plus 40. Divide by 2, divide by 2, divide by 2. This is y greater than or equal to negative 3 halves x plus 20. So let's plot this. We're going to start at 20 on the y-axis. And we're going to go down 3. 1, 2, 3, and over 2. I'm going to do one more just because I need help graphing. Now, I have to make a choice here. When I graph this line, am I going to shade above the boundary line or below? And am I going to draw a solid or a dashed line? Yeah, greater than or equal to is above, but still solid. So this time also, we're going to draw a solid line. These have all been solid. That's pretty nice. But instead of shading below, I'm going to take my shading and I'm going to shade all the way above the graph. So all of these coordinate points contained in the purple are options for Preston and Caleb to spend nice amounts of money on their mother and spend at least $40 to get her a really nice gift. Let's look at some combinations. Is it possible for them to spend get 14 chocolate chip cookies and get 15 sugar cookies? Absolutely, that's in the shaded region. Can they get their mother 2 chocolate chip cookies and 17 sugar cookies? Yes. Can they get their mother 7 chocolate chip cookies and 6 sugar cookies? No, that's not in the shaded region. They didn't spend at least $40, so that one is not a solution. Linear inequalities are actually really, really cool. We're going to spend some time working with them in mathematical situations in class. Most of the ones you saw here on your notes are real-world situations, which means they all kind of look the same. But I promise you, you will see some that have dashed lines when you come to class because those happen in more mathematical contexts and not in real-world context with the types of problems we're giving you. The one thing I want you to look at before you end your notes today is I want to make sure you realize how important this chart is. Every time I drew a line and shaded it in, I was having you refer back to this chart. So please make sure you look at this chart, highlight, circle, star, underline, annotate. Make sure you know what this chart is telling you because it's going to help you out on all of your notes for the next couple days. See y'all in class. We'll graph some inequalities together.